Okay, now we're going to do radicals. Radicals are expressions that involve the square root of an unknown. The radicand is the expression under the radical sign, so right above the 9 is the radicand. An entire radical is numbers only under the radical sign, so the 9 would be an entire radical, but a mixed radical are numbers before the radical sign. So if there is a number before this whole thing, that would be a mixed radical. Steps for simplifying radicals are first express it as a perfect square and another number, and then second would be square root the perfect square and leave the other factor under the radical sign. So now we're going to simplify radicals with examples. A radical is in its simplest form when the radicand has no perfect square factors, it does not contain a fraction, and no radical appears in the denominator of a fraction. So our first example is square root of 27. I know what can go into square root of 27 is 9 and 3. The square root of 9 is 3, and you leave that 3 there. So this is the simplest form I can get into because I can't simplify the 3 anymore. So now we're going to go into a harder example. It's square root of 486. So I know what can go into it is 9 times 9 is 81, and 81 times 6 is 486. So it'd be 81 and 6. I know the square root of 81 is 9, and you leave that 6 there. So I can't simplify this anymore, so that is all you need to do. So now we are going to multiply and divide radicals. To multiply and divide radicals, you will need to place the two radicands under one radical as a product, then multiply or divide factors, then simplify. So basically it's just multiplying it. So 4 times 13 is 52. And that's it. You're done with it. And now we're going to our second example, which is square root of 8 divided by square root of 2. So forget about the radical sign, and you basically just divide 8 by 2. So 8 by 2 is square root of 4, and the square root of 4 is 2. So now we're going to go into a harder example. So 225 divided by 5, which is 45. So you just write square root of 45. You can simplify this, and it will be 45 divided by 9 is 5. So you would put 9 and 5, and it would equal 3 and square root of 5. So now we're going to rationalize the denominator. Rationalizing the denominator is multiplying the numerator and the denominator by the radical in the denominator. So for this equation, it's 3 divided by the square root of 5. So to get rid of this radical inside, you'll have to multiply 3 and square root of 5 by square root of 5. So now it'll be like this. So this will now become 3 with the square root of 5. Since these two cancel out, it'll be just 5. So now your end result is 3 with the square root of 5 divided by 5. So for example 2, you will have to multiply 5 divided by 7 and the square root of 10 by the square root of 10. So this will now become 5 divided by the square root of 10 and 7 times 10. So you have to remember that since these two cancel out, now you will have to multiply it. And that will be 5 with the square root of 10 divided by 70. That is your end result. Now we're going to learn combining radicals. For combining radicals, you just have to leave the radicand the same. You don't need to multiply or add anything. So for this one, I know what's under the radicand sign is all the same because each of these radicals have the same number. So this is a combined radical. For this one, 8 and the square root of 2 cannot be simplified anymore because I cannot simplify 2. But I know that I can simplify 8. So for 4 and the square root of 8, it can be square root of 4 and the square root of 2. And since the square root of 4 is 2, you multiply 4 by 2. And you leave square root of 2, and that will now become 8 with the square root of 2. And now these are and the square root 8 and the square root of 2 and 8 and the square root of 2 are combined radicals. Now we are going to add and subtract radicals. Adding and subtracting radicals so basically you have to express all radicals in their simplest form and collect like radicals, just like collecting like terms. For this one, each of the radicands are the same, so it'd be 2 minus 1, which is 1, and 1 minus 4, which is negative 3, and just radicand 10, square root of 10, and then you just add the 5, because the 5 does not have a radical. For this one, you would have to simplify a lot more. So for 4 and the square root of 18, I know that 9 and 2 can go into 18. So 4 and square root of 9 and square root of 2. I know the square root of 9 is 3, so you would have to multiply 4 by 3, and then the square root of 2, and that will now become 12 and the square root of 2. For 3 and the square root of 50, it will become 3 and the square root of 25 and square root of 2. I know the square root of 25 is 5, so you multiply 3 by 5 and the square root of 2, and that would equal 15 and the square root of 2. For this one, I know that 102 go into 200, so it would be square root of 100 and the square root of 2. So that would become 10 and the square root of 2. Now I know that all these radicals are the same, so now I can finish the question. So it would be 12 and the square root of 2 plus 15 and the square root of 2 plus 10 with the square root of 2. And that will become 12 plus 15 is 27, and 27 plus 10 is 37 with the square root of 2. Remember not to add the 2's because you just leave them there. So that is the end result.